Hey, Mr. Mutford here. We're just going to take a basic integral and then show you pictorially why integration by parts essentially works. It's not just this algebraic manipulation of the product rule into some convenient form for later use. Let's make it believable to you. So integral of f of x dx, right? We take all the heights, cut it in these little dx slices, add them all up with the integral sign, and you have the area under the curve. So let's do this, but I'm going to relabel these. The height will now be u instead of y, and the horizontal will be v instead of x. And now what we're going to do with this is, I put it in that box. We're going to take the whole box, and we're going to cut off the part we don't want, this top above part, so that we're left with the area under the curve. So now, here's what this formula is. That's just height times all the dv's added up with an integral sign, just like we had from day one of integral. The whole box, base times height. This is not a surprise. And then over here, we're going to subtract. Now we gotta be careful here. The cuts are the little du's, and we're cutting from this side up top here, but we're adding up all the v's. That's the horizontals now. But this is the integration by parts formula. It is pictorially shown. You can believe that if you had a piece of paper and cut out the part you don't want, you get the part you did want. But the formula is using this key definition here. Make all of this make sense. And now when you play around with the algebra steps and the product rule, hopefully it's a lot more believable to you. Also, if you ever forget what's going on, you can derive this from the pictures instead of from the actual product rule algebraically. All right, I hope that helped.